You likely hear phrases like data-driven decision-making, artificial intelligence, and AI, or terms like data science and data analytics nearly every day. This begs the question, what is data? Hello, welcome back to the Quant Plus YouTube channel. Today we will be introducing and defining the concept of data. Intuitively, anything that can be observed and measured can be considered data. Let's work through a few examples and make sure we have the idea down. Is someone's height data? What about their weight? Hair color? Eye color? Whether they're wearing pants? Well, how about how much rain fell in your city last week? All of these are data that can be used to answer different questions. Broadly speaking, there are a few important classifications of data one should know. First, qualitative or categorical data, here on the left, refers to things that are not measured numerically or with numbers. Then, within qualitative data, you have nominal data and ordinal data. As the name suggests, when dealing with ordinal data, the order of things matters. So, for example, if we think about a student government, if we have distinct positions such as president, vice president, secretary, and so on, that would be ordinal data, right? Because we're assuming that different positions have different responsibilities and can be thought of as being more powerful or less powerful. On the other hand, if we're to continue thinking about a student government, if we were to say we have a 5-person committee, then this would be nominal data, right? Because we're assuming that all people on the committee have equal responsibility and equal power. Next, quantitative data refers to measurements made with numbers. Although this is not a hard and fast rule, and eventually you will see some exceptions to it. Within quantitative data, we have discrete data, or measurements that can only take a few specific values, and continuous data, measurements that can take any value in a specified interval. So, as an example, for discrete data, the number of people is a common example, because it doesn't make sense to have a fraction of a person, right? You have 0 people, 1 person, 2 people, and so on, where each of these are whole numbers. On the other hand, rainfall or snow are 2 common examples of continuous data, because you can have any amount of rain or snowfall. As an example, if we're in the United States and measuring things in terms of inches, it's possible that you have 0.00001 inches of rain in a day, and it's also possible that you have 5 inches of rain in a day. These distinctions in data are important because they inform how we represent and analyze data. For example, if you're considering the colors of cars on the road, there's no inherent ordering to colors unless you go out of your way to think of things like Roy G. Biv, right, in terms of the visible colors, or the electromagnetic spectrum in terms of radio, microwave, infrared, and so on. Therefore, trying to calculate quantities or measures like the largest or smallest values don't make sense, right? These measures don't make sense because what value are we assigning as the maximum, and what's the justification for it? On the other hand, determining the most frequently occurring value does make sense in that scenario. So, in summary, data is everywhere, and understanding the types of data helps us better work with data. If you found this content informative, please support the channel by liking this video and subscribing. You can also schedule your first tutoring session today by following the link in the description. Have a great day.